equation for the capacitor. As frequency F increases, Xc decreases. For a given voltage, the current would increase as frequency increases. A battery voltage is DC, that is, it doesn't vary. The frequency F is zero, therefore the reactance is infinite. Capacitors will not pass a DC current. They are sometimes referred to as DC blocks, as they will pass AC, but not DC. Consider the equation for the inductor. As frequency F increases, XL gets larger. For a given voltage, the current through the inductor would reduce as frequency increases. Remember, a battery voltage is DC, that is, it doesn't vary. The frequency F is zero, therefore the reactance of an inductor at DC is zero. Inductors present a very low resistance, almost a short circuit, to a DC voltage. If an inductor was placed across a DC voltage, a very high current would flow, causing damage to the inductor. For this reason, inductors should never be connected across a battery or DC power supply. Is a form of electromagnet. Current flowing through its coils causes the magnet to activate a switch. The way in which a typical relay works is shown below. The relay has a number of uses. For example, the switch can be designed to carry much more current than is required to operate the relay. A car starter motor needs about 100 amps to start, a huge current. If this current passed through the ignition key switch, it would burn out the switch. About 1 amp is required to activate a relay, or solenoid as a car mechanic would call it, which closes a very large switch, allowing 100 amps to pass to the starter motor. The circuit is shown below. Another use for a relay is in a circuit that latches. An example of a latching circuit is the steady hand tester. Here, if you touch a bendy wire with a ring, a lamp lights and remains lit even when you separate the wire and the ring. Note, the reset has to be a push-to-break switch. The lamp can be turned off only by opening the reset switch, which should be closed again before the circuit can be reused. Relays and transistors. It's common to find a relay being operated by a transistor. This makes it much easier to use in a sensor type of application, such as switching a light on when it becomes dark. The circuit below shows this. In this case, darkness falling causes the resistance of the light-dependent resistor to rise, and the voltage at point A will also rise, activating the relay which causes the mains lamp to light. Note, a diode is connected across the relay. This prevents large voltages developing across the transistor when the relay is switched off. This diode is called a flywheel diode. Time delay circuits. The fact that a capacitor takes a certain time to charge to a given voltage makes it possible to delay the operation of a circuit. In order to keep the current small, a transistor switch is often used. Take as an example the internal light in a car. On most cars, the internal light comes on when the door is opened. These often stay on for a short time after the door is shut again. This delay in switching off is achieved using the circuit shown. The lamp will light if the voltage at point A is above 0.7 volts. Someone opening the door will have the effect of closing the switch. The voltage at point A will rise to 12 volts and the lamp will light. Closing the door causes the switch to open, but the voltage at point A will not change immediately. Instead, the capacitor will charge up and the light will switch off when the capacitor voltage VC reaches 12 minus 0.7, leaving 0.7 volts at point A. The graph shows how the voltage at point A varies. As a guide, the delay introduced is about 3 CR seconds with a 12-volt power supply. You can see that the capacitor is an electrolytic type. This is because the capacitor must be quite large, several thousand microfarads, in order to give a reasonable delay. If the position of the capacitor and resistor are reversed, the circuit will delay before switching on. In this case, the switch is closed to keep the lamp off. Once the switch is opened, the capacitor will charge up and the voltage at point A will rise. Once this voltage reaches 0.7 volts, the lamp will light. Because the capacitor needs to charge to only 0.7 volts, the delay introduced is less, about 0.05 CR for a 12-volt supply or 0.12 CR for a 6-volt supply. Remember, it is the product of multiplying C by R that affects the time delay. As a guide, the delay introduced is about 3 CR seconds with a 12-volt power supply. You can see that the capacitor is an electrolytic type. This is because the capacitor must be quite large, several thousand microfarads, in order to give a reasonable delay. If the position of the capacitor and resistor are reversed, the circuit will delay before switching on. In this case, the switch is closed to keep the lamp off. Once the switch is opened, the capacitor will charge up and the voltage at point A will rise. Once this voltage reaches 0.7 volts, the lamp will light.
Which combination of unit is equivalent to the what? What is the value of resistor if it is fed 9 watts when a current of 12 ampere flow through it? Give your answer in ohms. What current flow in the 2 ohm resistor? So, the circuit. Give your answer in ampere. Okay. How much current flow to this resistor? What is the resistance of this network? Give your answer. Pertanyaan berapa? Sorry. Okay. Here a node in the power circuit. What is the value of the current out? This one. This node. Intra. Extra. Incoming. Outcoming. Okay. Which formula give the representation of the capacitor? You can choose this one, A, B, C, D, F. Okay. Second, here is description of the component. What is it? A switch operated by a metronome. Okay. Okay. The transistor is being used to operate the relay coil. This is relay coil. Transistor. This is X. What is the command marked as X? The practical unit of capacitor is microfarad. Symbol for is this. Okay. Okay, the last one is if 1 microfarad capacitor is in series with 1 k-watt resistor, what is the time constant in millisecond? Okay. I think this one is k ohm, yeah, not k-watt. K ohm. K ohm. Okay, finish. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.